Okay, let's take a look at a couple of application problems. Again, this is lesson 9.2 and it's part B. So the other day we looked at the quadratic equation for the dropped object. Today we're going to be looking at the vertical motion model. And the difference here is that we're going to have a B value right here, and that is the velocity. So let's look at our example here. We got Daniel kicks a soccer ball up into the air with an initial upward velocity of 64 feet per second. The ball is 2 feet above the ground when it's kicked, and we're asked two questions. How long will it take the ball to reach its maximum height, and how high above the ground will the ball be when it's at its maximum height? Well, to make this easier to understand, sometimes it's best to start with just like a little picture of what's happening. Okay, so Daniel's kicking a soccer ball up into the air. The ball's 2 feet above the ground when he begins to kick it. So we're just going to say the height right here, we'll just call this 2 feet. And Daniel's going to kick the ball. It's going to go up into the air and then it's going to come right back down due to gravity. Okay, so we're wondering how long it's going to take the ball to reach the maximum height and how high above the ground is it going to be. Well, let's take a look at our graph. When the ball is at its maximum height, that's right here. And what's this called? The vertex. So the vertex is going to give us a point, an x and a y. The x is going to be the time, and the y is going to be the height. So by finding the vertex, we're going to figure out the time, how long it takes to get to the maximum height, and how high it is. Just by finding the vertex, that's all we need to do, and we're going to have our questions answered. So let's first start off by writing a quadratic equation using the vertical motion model. Okay, so I've got h equals negative 16 times time squared plus, now remember here I need to add my velocity. So velocity is 64 feet per second. So 64 times t plus, and then the c value here, if you look back at the dropped object model, remember the c value was the starting height. And so that starting height is 2. Okay, so here's my quadratic equation. Now remember this comes from y equals negative 16x squared plus 64x plus 2 if you write it in terms of x and y. Okay, so in order to find the vertex right here, we can use that formula that says x equals negative 2 over, negative b over 2a. Well, that looks really bad. Let's make that a little bit prettier. There we go, negative b over 2a. So that's the formula that we're going to use to help us find the x coordinate. So we've got x equals negative b. The b value is 64. So negative 64 over 2 times a, and our a is negative 16. Okay, so if I simplify this, this is negative 64 divided by 2 times negative 16 is negative 32. So if you take negative 64 divided by negative 32 in your calculator, you're going to get x equals 2. And that's the x coordinate of the vertex. So I'm going to put that right here. That's 2. Okay, so now we need to figure out the y. So remember, we're going to be plugging in 2 everywhere where we see x into the quadratic equation so we can find y. And remember, y is referring to the height because that's what's on the y-axis. So we've got negative 16 times 2 squared plus 64 times 2 plus 2. So we're going to go ahead and type all of that into the calculator using your parentheses buttons. Let's figure out the value of y. So calculator is going to tell you 66 when you type all of that in. So I'm going to go over here to the vertex. I'm going to put 66. There we go. Put the parentheses there and there. Okay, so 266. Okay, now I never would normally say this to erase your work, but just so I have a little bit more space here, I'm going to erase my work. That way you can see me answer these two questions. Okay, our two questions. Switching colors here. Okay, first question we have is how long will it take? Oops, I'm on eraser. How long will it take the ball? And then how high above the ground will it be? Okay, so our vertex is going to give us those answers because this is our maximum height. So the 2 that we got, remember this is our 2, 66. Our 2 that we got is representing the time. So 2 seconds right here. 2 seconds. And so it's going to take the ball it's going to take 2 seconds. And the maximum height here is the y right across here. And that y value is 66 feet. So when Daniel kicks the soccer ball at 2 seconds after the kick, it's going to be at the highest point, and that's 66 feet before it starts to turn back down and head down to the ground. Woo, we did it. Okay, let's do one more application like this. Okay, here's our second one. During a halftime of a basketball game, a slingshot 5 feet off the ground launches t-shirts at the crowd. A t-shirt's launched with an initial upward velocity of 72 feet per second. Wow. Okay, let's quickly just kind of graph what's happening just to give us an idea of what this looks like. So we got 5 feet off the ground. Let's just, whoops. Let's just go ahead and just call this 5 feet. Okay, so it's going to go, the slingshot's going to sling it all the way up, and then it's going to turn and it's going to come back down, and somebody's going to catch it somewhere along here, probably, right? Okay, two questions were being asked. How long will it take the t-shirt to reach its maximum height, and what is its maximum height? So again, if you look at the parabola that the t-shirt's going to make after it's being launched, this right here is the maximum height, and that is the vertex. So if we find the vertex, the x-coordinate will tell us the time, and the y-coordinate will tell us the height of the t-shirt. So let's first write our, I'll keep blue, let's just first write our vertical motion model, our equation. So we have h equals -16 t squared plus, and v represents our velocity, and that's 72. Okay, and then we've got plus our c value, which is our starting height, which is 5 feet off the ground. That's the slingshot must be set up 5 feet above the ground. So there's our function. We need a function. Okay, now we want to find the vertex. Remember that equation to help us with the vertex, x equals -b over 2a. I'm going to get it right this time. Okay, so here's our a, here's our b. So we got x equals -b, so -72 over 2 times a, which is -16. So this is -72 divided by -32. And you use your calculator to do that. And your calculator is going to tell you that x is equal to 2.25. Okay, so x here is 2.25. And now remember that x is referring to the time. So at the maximum height here, it's going to take 2.25 seconds to get to the maximum height, which is very quick. Think this is a slingshot, right? Okay, so we want to know what is the maximum height. We're going to need our y value because the height is y. So we're in place of x or t, in this case it's a t, we're going to plug in the 2.25. So height equals -16 2.25 squared plus 72 times 2.25, that's our time, that's why we're plugging it in for t, plus 5. So you're going to use your calculator to type all of that into the calculator. And that's going to give you the height, the y, which is our height. And when you plug all that all into the calculator will tell you a nice round 86. Woo, 86. That's our y value. Okay, so let's erase for me, not for you, just so I have a little bit more space to put my answers here. Okay, so how long will it take? That's our x, which is 2.25 seconds. Not going to take a whole lot of time when you're slingshotting a t-shirt. Okay, 2.25 seconds. And what's the maximum height? That is 86 feet high that the t-shirt's going to be before it starts dropping back down. All right, there we did 2 application problems using the vertical motion model. Very fun. Okay, so we've got summary here. So go to your summary page of your notes. Couple things to fill in. Find the vertex by using this formula. That's going to help you out with your vertex. Remember that that formula is for the axis of symmetry. Then step 2, plug the x into the original equation to find the y so that you get your vertex point. This is what you do when you graph. Once we get that vertex, remember that's the middle point of our parabola. And so once we get that, we want to choose 2 values for x that are above the vertex and 2 that are below the vertex for our domain. So the summary here is just a little reminder of steps to graph a quadratic function, and that's really what we did in part 1 of lesson 9.2. Thank you for joining me. Have a great day.